Namaste dosto. Imagine you are drawing a perfect circle and placing 4 dots anywhere on its edge. What shapes can you form? Well, if you join those 4 points on the circle, you get what we call a cyclic quadrilateral. Simply put, a quadrilateral is called cyclic if all its 4 vertices lie exactly on the circumference of the same circle. Let's name this quadrilateral ABCD. Because all 4 points are on one circle, they are concyclic. Now, here's a very interesting property. The sum of the measures of opposite angles, that is, angle A plus angle C, is always equal to 180 degrees. This is both a necessary and sufficient condition, which means if a quadrilateral is cyclic, its opposite angles add to 180 degrees, and if the opposite angles add up to 180 degrees, the quadrilateral is cyclic too. You might wonder about the diagonals here. Well, diagonals in a cyclic quadrilateral can be of any length. They don't have to be equal. But no matter what, the opposite angles will always be supplementary, which means they add up exactly to 180 degrees. This special circle inside which the quadrilateral sits is called the circumcircle of the quadrilateral. Picture this, a circle with a cyclic quadrilateral ABCD snugly inscribed in it, and all the 4 angles clearly marked. Keep this image in your mind as we move forward. Now that we have identified the cyclic quadrilateral, let's zoom in on one of its most important theorems. The opposite angles are supplementary. This means in a cyclic quadrilateral, angle A plus angle C equals 180 degrees, and the same goes for angle B plus angle D, also 180 degrees. But why? Picture the arcs on this circle. Angle A actually intercepts the arc BCD, and angle C intercepts the arc DAB. The measure of angle A is half the measure of arc BCD, and angle C is half the measure of arc DAB. Since arcs BCD and DAB together form the entire circle, which is 360 degrees, the sum of the 2 intercepted arcs is 360 degrees. So, if we add angle A and angle C, it's like taking half of the whole circle, which gives us 180 degrees. This relationship holds firm no matter what the side lengths or diagonal lengths are. So remember, no matter the shape, as long as the quadrilateral is cyclic, this supplementary property of opposite angles will always be true. Imagine the circle again with marks on the arcs and the opposite angles, and you'll see how beautifully these relationships fit together. Time for an exciting flip. We already know that for cyclic quadrilaterals, opposite angles add up to 180 degrees. But did you know the opposite is also true? If a quadrilateral has opposite angles summing to 180 degrees, then it must be cyclic. This is called the converse of the cyclic quadrilateral angle theorem. How do we prove it? Well, start by constructing a circle through any 3 vertices of the quadrilateral since a unique circle passes through any 3 non-collinear points. Then, using some neat angle calculations and the properties of circle geometry, we can show that the 4th vertex must lie on this very circle as well. This means the entire quadrilateral is cyclic. So, if you ever find a quadrilateral where angle A plus angle C equals 180 degrees, and angle B plus angle D equals 180 degrees, you can confidently say that all 4 points lie on the same circle. Picture an arbitrary quadrilateral with these angle properties and visualize how it snugly fits inside a circle. Amazing, right? Arey vah! Now let's explore a very unique and handy property of cyclic quadrilaterals, the exterior angle property. In any cyclic quadrilateral, the measure of an exterior angle is always equal to the measure of the interior opposite angle. For example, if we extend side CE outwards from vertex C, forming an exterior angle at point E, labeled as angle DCE, then angle DCE is exactly equal to angle B, the interior opposite angle. How does this work? Well, from the supplementary property, angle C plus angle A add to 180 degrees. Also, angle DCE plus angle C equals 180 degrees because they form a linear pair on a straight line. By equating these 2 facts, you get angle DCE equals angle A. This special equality is unique to cyclic quadrilaterals and very useful when solving tricky angle problems, what we call angle chasing problems. Imagine the cyclic quadrilateral ABCD with the side CE extended and both the exterior angle and its opposite interior angle marked. Keep this property handy. Let's put our knowledge to work with a simple example. Suppose in cyclic quadrilateral ABCD, angle A is given as 70 degrees and you are asked to find angle C. What will you do? Remember the key property. Angle A plus angle C equals 180 degrees. Step 1. Plug in the known value. 70 degrees plus angle C equals 180 degrees. Step 2. Solve for angle C by subtracting 70 degrees from 180 degrees, leaving you with 110 degrees. So, angle C is 110 degrees. Shabash. You have successfully applied the cyclic quadrilateral property to find an unknown angle. Imagine the cyclic quadrilateral with angle A marked 70 degrees and angle C waiting to be found. This practice will really build your confidence. Let's try one more example using the exterior angle property. In cyclic quadrilateral ABCD, imagine the side extended from vertex C to point E, forming an exterior angle DCE, which we call X. If angle B, the opposite interior angle, is 60 degrees, find the value of X. From the exterior angle theorem, we know that the exterior angle DCE is equal to the opposite interior angle B. So that means X equals 60 degrees. Simple and straightforward. This confirms that our theorem works perfectly in practice. Picture the quadrilateral ABCD, the extended side CE from vertex C, and the angel's X and be clearly marked. Excellent beta. Now you have two powerful tools. Opposite angles supplementary and exterior angle equals opposite interior angle. Let's quickly wrap up what we learned about cyclic quadrilaterals. First, the most important formula. Angle A plus angle C equals 180 degrees and angle B plus angle D also equals 180 degrees. Next, remember the exterior angle equals the opposite interior angle. Third, if in any quadrilateral the opposite angles are supplementary, then the quadrilateral must be cyclic. Keep these key ideas in mind. Cyclic quadrilaterals always have all vertices lying on a single circle. Opposite angles being supplementary is both a necessary and sufficient condition, and the exterior angle equals the opposite interior angle is a unique and very useful property. These are your go-to facts when dealing with cyclic quadrilaterals in exams or problem solving. Soch ke dekho. How many angle problems can be simplified just by knowing these properties? Fantastic. Keep practicing, and soon these theorems and properties will become second nature for you.